Number 4 is kind of a nice transition from where we finished last time. So let's talk this one through. Let's talk through those questions and thoughts that we did last time. Let's remember that the word solve means isolate. That's right. And so you look at the n right now. What I'm going to do is I'm going to draw a little highlight on the equal sign. And so we're looking on the left side. You can see that the n is not by itself, right? Cooper, what's with the n? 14. So then how is that 14 attached to the n? Is it 14 plus n, 14 minus n? Multiplication. So remember, we're trying to get rid of anything that's with the n, right? So how do you get rid of, or how do you undo multiplication?
You have to divide, or you have to do the opposite, basically. So
Yep.
14 divided by 14n. And that
Because, hold on, go back. You said divide by
14n.
not 14n. Remember, what we're trying to do is we're trying to separate the 14 and the n.
Yeah.
So if I divide by 14n, aren't I keeping them together?
Yeah.
So I don't need to divide by 14n. I need to divide by 14. There you go. All right, so we divide this side by 14. But as you guys know, we are not allowed to do that because what I've just done is I've unbalanced the equation. So how do I rebalance the equation? Ashley. That's right. We've got to do the exact same thing to both sides. So we divide both sides by 14. This might be where your calculator becomes a little more useful. As you guys know, these are available to you in the second chapter. The 14s cancel out, or they divide out. We end up with n is equal to, did anybody do it yet? Gracie, what'd you get? 11 is right. So n is equal to 11 for this one because we divided both sides by 14. This is that property of equality, right? You are allowed to divide both sides by 14. I need to see that. Okay, so make sure you show that. Do you guys have any questions about that one? Okay. Anybody? Okay, so then number 5, similar, says x over 3 is equal to 12. X over 3 is equal to 12. So once again, we are going to look at this as a balancing act. You know, is the x currently, is it already by itself? It never is, right? That's kind of the point of this. Avery, what's with the x?
3.
There's a 3. How is that 3 attached to the x?
Division.
So what do we do to get rid of that 3?
So apply 3 times 3 and then do 2 like that too.
Yeah, so multiply both sides by 3 is what she said. So what I'm going to do is, I'll rewrite it, I guess. X over 3 equals 12. I'm going to multiply the left side by 3 and the right side by 3. Can anybody think of a way to make the left side look a little bit easier? Because right now it's like 3 times a fraction. What little thing might we do to make it look a little more easy? Yeah, Garrett, what do you think? Yeah, make it 3 over 1. That way you can distinguish the numerator, the denominator a little bit easier. Makes sense. Okay. So on the right side, you guys know 12 times 3?
36.
36 is right. And then effectively, what happens on the left side with the 3's? Remember that the cross-canceling thing we've talked about? Yeah, so the 3's effectively just cancel out. You're left with x over 1, or you could just leave it as an x. What do you think? Yeah. Any questions? So these have all been one-step equations. We're going to go to the board now and do some practicing with the practice at the board, okay? So let's head back up to the board. We'll do number 6. See how you do with this one. Ready, set. There's some really great examples. Can I show you what I would recommend? Because there was 2 different ways, and they were both really nicely done. Really, really excited about that. That was good. Let me show you what I feel like is the quickest way to handle this. When you've got a fraction like this, 3/5 hanging out, and you're trying to deal with that as far as solving an equation. 3/5 obviously is written in fraction form right now, and we want to get rid of it, right? Because it's clearly 3/5 times x. You could, by all rights, you could look at this and say, well, it's 3/5 times x, so why don't I divide by 3/5? And there was, I think, several of you that did that, and you did that really, really well. Another way to look at it, like some of your classmates, is a way to get rid of a fraction is to use the inverse property of multiplication, right? Or what we refer to loosely as the reciprocal property. Let me see if we can fill in the blank. Any number times its reciprocal is 1. And so you could have looked at it and said, you know what, I want to get rid of that 3/5. Why don't I just multiply both sides by 5/3? Which really is the same thing as dividing by 3/5 if you think about the copy.flop, right? Didn't you, if you divided by 3/5, didn't you eventually go times 5/3? It really is the same thing. You could do it this way, makes it a little bit quicker, but the division that we saw from some of you works just fine as well. So then 9 over 1 times 5 over 3 does end up being 15. So that was quite well done. Great job. Okay, take a look at number 7. Let's head to the board and try that one, and we'll get this wrapped up. Could be rewritten slightly to help us understand what to do. How could I rewrite negative t to help me understand how I should do the algebra? What do you think, Anna?
Negative 1, 2.
That's right. It really is negative 1 times t equals negative 8. So when you look at it from that perspective, you can see a little more clearly like what is actually being attached to the t, and then also by extension how to get rid of it. So we would divide both sides by negative 1 would be a way to do this, and negative 8 divided by negative 1, of course, a negative divided by negative is a positive, so positive 8. Okay, so that's kind of the last one-step equation we're going to do here together, at least for the moment. Do you have any last questions, any follow-ups that I can try to answer for you? All right, so let's move on then to our next section, and we'll take today and all of next class period as well to do these. And so let's talk about this really quick. Section 2.2 is more solving equations. These are basically going to be somewhat more complicated. Instead of one step, it's going to be more than one step. So I want to kind of help you guys with my philosophy on this. We are going to have to do some simplifying first in some cases, but after we have simplified, we are always going to follow the same order of solving. And I want to point out where this comes from. Does that look familiar to you guys?
Yeah, it's PEMDAS.
Isn't that PEMDAS backwards? SADMEP, right? PEMDAS backwards. So when we were talking about doing order of operations to evaluate expressions, we always did PEMDAS. We did the work in the parentheses first, and then we did exponents, et cetera, et cetera, et cetera. So when we're solving, instead of like putting things together, solving is actually kind of breaking things apart and taking things away from the variable. And so once we have simplified any distributive properties or maybe some like terms that need to be added, once we've gotten to that point, we're going to try to SADMEP it. Okay? So we will undo subtraction or addition first, and then we would undo any division or multiplication. And that's at this point, that's kind of where we'll end. We won't get into exponents or parentheses yet, but that would be the order in which we would try to handle this. And so I want to show you an example or two. We'll go to the board and try to practice these. So take a look at number 1. Number 1, again, the instructions are simply to solve. And it says negative 9x plus 7 is equal to 34. And so look at that left side. Is the x by itself right now? It is most definitely not by itself. There's two things attached, right? What are the two things attached to the x?
And 7.
In other words, what are the two things with the x on the left side?
Negative 9 and 7.
Negative 9 and 7. Now, how is the negative 9 attached?
Multiplication.
Multiplication. How's the 7 attached? Okay, so here's where we got to make a decision. There's going to be an easy way, there's going to be a hard way. The easiest way is to follow SADMEP. SADMEP. So we're going to undo any subtraction or addition first. You don't have to do it this way. This just typically makes it a little bit easier. So, am I going to get rid of the negative 9 first, or am I going to get rid of the 7 first?
7.
Okay, so how am I going to get rid of the 7? What do you think, Sadie? I'm not going to add it, actually. I'm going to subtract it. Why would I subtract it? You've got to do the opposite. Right now it's plus 7, right? Yeah, so we're going to undo it by doing the opposite. So minus 7 from both sides. Does that make sense? Okay, so I'll draw my little line here, and I will execute that subtraction. So I get negative 9x is equal to 27. So this is not a one-step equation because I'm not done yet, right? I did one step, but I'm still not there. The x is not by itself. Lana, I still got that negative 9. What do you think I should do to get rid of that negative 9? Divide
by negative 9.
On both sides. That's right. So I'm going to divide both sides by negative 9. And when I do that, the negative 9s cancel out. What is 27 divided by negative 9? Negative 3. So if you were going to label these types of equations, you maybe would call them two-step equations because it takes two steps. You undo the addition or the subtraction first, and then you undo the division and multiplication. And that ordering, I think, is very helpful to make these as easy as can be. Take a minute here with your table partner. Let's see if you guys can handle number 2 together. Work it out on your paper. We'll check your answer here in just a second. Let me just quiz you on this. Will, what'd you do first?
I added 3 to both sides.
That is an excellent move. Why'd you do that?
To get rid of the 3 on the right side of the bar.
And you undid subtraction or addition first, right?
Yeah.
Okay, makes sense. Good job. Okay, so then you get 4/9 r equals negative 20. Did I mess up? Is that right? Okay, we're good? Okay. Kendall.
Okay, so then what I did is I multiplied both sides by 9/4.
Why?
Because then it cancels out the 4/9.
Yeah, the reciprocal thing, right?
Yes.
Exactly, that's great. So we multiply this side by 9/4, multiply the other side by 9/4. Kendall, to make the right side easy, did you do anything special with the negative 20?
I put it over 1.
Yeah, I think that makes sense. That makes sense to the rest of you guys? That way the denominator, the numerator becomes more clear, right? How we handle the multiplication. So over here, the goal was to get everything to cancel, and we can see with that cross cancellation idea, everything did cancel, right? So that's great. And then on the right side, we get this negative 20 over 1 times 9/4 thing. How did you handle that? Anybody? I mean, Kendall what's your response since you
Okay,
started?
so for the negative 20 and the 4, I crossed out the 4 and made it 1, and then
Okay.
I crossed out the negative 20 and made it 5 because 4 goes into 25 times.
Maybe negative 5?
Well, yeah.
Okay, yeah. And now the multiplication becomes even more simple, right?
Yes.
So negative 5 times 9, negative 45. Question, Mr. Champion.
What is the S step? Like, so I see the add subtract. What's the S in the SE or SAD?
So SADMEP. So this just means undo subtraction or addition first.
Okay, so I see the slash. All right.
Yeah, I think, was there slashes on that? Yeah.
So there's a space between the A and the D.
Yeah. So yeah, you'd circle the S/A and the D/M. Yeah. That was a good question.
Oh. I thought, oh my gosh.
Isn't it great that he just asked that question because now Grace gets something that maybe she was confused on, right?
Well, yeah, but I thought it was saying like do subtraction, then do addition and division.
Oh,
and
yeah.
then multiplication. Cause
So I need to change my graphic a little bit, don't I? I can do that. I can do that. Hey guys, any other questions before we move on to our final example before we go to the board? Okay, so I want to do this one with you, and we'll practice this kind of thing at the board. Number 3, look carefully at number 3 and think about what you've done with number 2 and number 1. How is number 3 different than numbers 1 and 2? What observations? Victoria, hey guys, listen.
There's an X on both sides.
That's major difference, right? There's an X on both sides. And so with an X on both sides, this is kind of the first time where we got to do a little bit of simplifying before we think about SADMEP or any of those equation solving steps. Can I give you like a slightly unpleasant saying that might help you remember the easiest way to do this? Is that okay? Some of you might be sort of offended by this. It's really not that bad. So you see, of course, as was mentioned, there's an X on both sides. There's a 5x, there's a 3x right there. So you have an option. You don't have to do it the way that I'm going to explain how to do it, but I think this is a good way to remember what to do. Do you see how one of the coefficients is a 5 and the other one is a 3? Obviously, one number is larger than the other, right? So in an effort to make this as simple as possible, here's my saying. Whenever you've got an X on one side and an X on the other side, kill the little one. I know it's a little off color. I'm sorry for that. But usually the things that are weird or maybe offend you slightly, you remember. And so maybe you'll remember this. So what we're going to do is we want to kill the little one. And the little one is the 3x, right? It's not the 5x. The 5x is bigger in this case. So the way we kill the little one is we subtract 3x. We want to get it to the other side. And since it's a positive 3x, the way that we kill it is to subtract it. That make sense? And so we've moved it over to the other side. By doing that, we've got, well, let me ask you guys, what is 5x minus 3x? 2x, okay, good job. Remembering that from last chapter. 2x minus 4 is equal to 10. And you see how now that we've done that, this looks just like the other ones we've done, right? There's addition, subtraction, and multiplication. We can undo those things. So would you guys finish this one really quick, just to maybe cap it off, and then we'll head to the board. Okay? Ready, set, go. If you haven't already looked at this one, try to finish this one off. And then I'll let you kill the little one yourselves later. Sorry. I didn't make that up. I'm copying someone else, but whatever. I know you can hear me. I know you can hear me. Gracie, would you help us out on this one? So starting at 2x minus 4 equals 10. Hey, guys, quiet down. Would you help us? What'd you do first? That's right. So we go plus 4 and plus 4. So we get 2x. The negative 4 plus 4 cancels, right? That was the goal. 10 plus 4, of course, is 14. Gracie has started us off really well. Carissa, can you take this one home?
Yeah, divide 2 by 2.
Divide both sides by 2. Yeah, exactly right. So dividing by 2, dividing by 2. Carissa, what'd you end up with for a final answer?
X equals 7.
Perfect. Okay. You have any questions? So we started off yesterday and early today with one-step equations. We kind of graduated to two-step equations. Let's go to the board. Let's make sure we're all doing great. All right? Ready, set, go. First group up. Close this off. We'll do a little bit more work before we finish, but let's close this part off right here. So what I would do with this one is I would recognize that I've got an x on the left and I've got an x on the right, and so I'm going to try to combine them. And really, the honest truth is all you got to do is kill one of them. Some folks killed the big one, other folks killed the little one. I'm going to always try to kill the little one because I know myself well enough to know I might lose a minus sign if I go the other way. So the first thing I would do is I would try to kill the little one. I would do that by subtracting the entire term, the entire 3x over. So minus 3x to both sides. That will give me negative 9 equals 3x plus 12. So that would be the first step that I would try to show. You don't have to do it that way. I just like this way as an organizational technique. I think it works well. Then I would recognize that the x over there on the right is not by itself. It's got a 3 and a 12 with it. Would I get rid of the 3 first, or would I get rid of the 12 first? 12. Right, we're going to do the subtraction or addition first. So I'm going to go minus 12 from both sides. And that would give me negative 21 equals 3x. And my final step would be to try to get rid of the 3, and I could do that by doing what? Dividing. That's right. So divide by 3, divide by 3. I end up with x is equal to, bless you, negative 7. Does that make sense? So I feel like maybe a few folks were moving things around without actually like adding to both sides or subtracting from both sides. That's why I want to see those properties of equality. There needs to be a good reason why the negative 9 went to the other side and like turned into a positive 9, right? Later on, we'll kind of streamline that process a little bit, but for now, we want to see that you added 9 to both sides. You subtracted 3x from both sides. I want to see that process, more or less, really, so that you understand what you're doing as you communicate what you're trying to do. Any questions? Any follow-ups from anybody? Okay, well, let's, I know it says practice at the board. I think I mislabeled a couple of these here. Let's do at least one more of these here, and then we'll head out, and know that we'll practice these again tomorrow. Okay, we'll practice all this again tomorrow and make a little bit of headway as well. So go back to your notes. Let's do at least one more here. Take a look at number 4. Right there. So we're not going to practice this one at the board. We'll practice this kind of thing at the board later. Here we go. So again, I think it's really important that we look at this and we try to understand how this relates to the stuff that we just did. This is clearly different, isn't it? Yes. Can anybody describe how this is a little bit different? It has what?
It has distributed.
It's got a distributed property. Did you all see that? So this is one of those simplifications that we need to do before we can get on with the SADMEP thing. We need to do any distributive properties that we see. Okay? And so what I'm going to do is that. I'm going to distribute. So if I distribute the 4, Hosanna, what happens when I distribute the 4? What results from that?
That would be 4x plus 8.
That's right, 4x plus 8. And then we still have the minus 7x and the equal 0. Has not gone anywhere. But you've definitely taken a big step as far as solving this. Now that you've done the distributive property, do you guys see how there's two different terms with an x?
Yeah.
What would you imagine we'd do? Combine them, right? You can add the like terms up, so let's add them up. What is 4x combined with negative 7x? Negative 3x, right? Remember, we add our like terms, we add the coefficients, and we leave the variable as is. So I'm going to write this as negative 3x plus 8 is equal to 0. And now we are hopefully to that more familiar SADMEP step, right? So what would you guys do first? Would you get rid of the negative 3 or the 8? And how would you get rid of the 8? You would subtract 8, that's right. So minus 8 from both sides. And 0 minus 8 is negative 8. So negative 3x equals negative 8. And then how would we finish this one off and get the x all the way by itself? Divide by negative 3 on both sides. You got it. Okay. Are you guys seeing? I think it's really important that we see how the finish to this one and really the finish to the ones we did at the board, isn't it the same as what we did at the start? It's SADMEP. You want to do subtraction or addition, then you want to do division multiplication. I just want you to see that commonality.
So if we were to have this question on a test, would you want us to completely reduce the answer or keep it as 8/3?
So 8/3 is reduced. It is reduced. It's not mixed number, which I think is what you're talking about,
Yeah.
right? I would really prefer the 8/3 because if you were to write 2 2/3, it's like, is it 2 times 2/3? Is it 2 plus 2/3? And we start throwing negatives in there. It gets even more confusing. Are they both negatives? Only one of them negative? And so I really, really prefer just the 8/3.
Okay.
Thank you. Yes, Ashlyn.
So how do you, like in the SADMAP, it says to do parentheses last,
So that's if
before.
you've already done simplification, right? So the one caveat, and I put that in the little notes with the SADMAP thing, is you want to simplify stuff first. So if you see a distributive property, go ahead and do the distributive property.
So if like the 4 wasn't there, then you would do the x plus 2 last.
Well, but if the 4 wasn't there, then the parentheses wouldn't need to be there either. And then you would just go x plus negative 7x is negative 6x. So that's why I kind of said, in our class for right now, the only parts we're ever going to really deal with are the SADM. Later on during the year, we'll definitely deal with the E. We'll have to solve when there's exponents involved. There might be 1 or 2 examples where the deal with the parentheses comes into play. But for right now, it's mostly going to be SADM. But the EP comes later. Yeah. Okay, do you guys have any follow-up questions on that one? Okay. All right, so when you come to class tomorrow, we will do a little reviewing, a little practicing. We'll push forward to the end. I'm encouraged by where you are right now. All right, so I hope you have a wonderful day. Chapel is next. Why don't you head down there? Enjoy.